Yeah, hello, welcome. Today on Tuesday, we have the 19th of January, CAD course number 9. This is the second last course, so one comes after us, and then we finish the first series of CAD course. So we have a much improvement since we started. But first, let's look back what was today and this week. So I need my I need my screen. So where we are here now. Okay. Yeah. So I want to show you what we are doing in the Space Hotel and the Space Education Institute now for everyone who is also in lockdown and must make homeschooling. So here you see Tara at homeschooling in her room. This is Cosma with her homeschooling. And this we do in the morning. Here is Jesko. Jesko's room is too full with toys, and so we are giving him a hotel room. So he lives in the space hotel room when he makes homeschooling. So everyone who needs homeschooling and has not much time and not much space at home, he should ask a hotelier. Maybe he can get a room for free for making his homeschooling. So afternoon, we see here, this is the CAD course on the computer, so everyone enjoys himself, he does something, and here Jesko is making an airplane, and Cosma is making a 3D printed MiniRover, and here is Tara, who is also looking how to do that. So, and here you see Jesko on the 3D printer, so everything is now ready that we can start to assemble a MiniRover or a MiniRover on our computer. This will be the course of today, but first let me show you what was this week. 2 days ago we had a very important day, because when we look now what was in space before, so we had a very, very important day 2 days before, because when you type inside Virgin Orbit, this is from Sir Richard Branson, one of his company. Then we had a very important flight this week, because Virgin Orbit is able or was able to send a rocket into the space, but from an airplane. So in this I want to show you now. I go a little bit forward here. So here you see the Boeing 747. This is a huge airplane. Under the wing you see the rocket, and the airplane is the first stage, and the second stage is the rocket. So you see it is linked off, starts the engine, and the rocket is starting now to fly to the orbit. And this was the demo flight. It was reality. So inside of this rocket is a payload. There are several CubeSats inside. And here you see the camera from the rocket, what flies now up to the orbit. So this is an altitude. Orbit is the altitude of 100 plus kilometers. So they set this CubeSats in the lower orbit, what is between around 200 kilometers. So, and you see one stage is complete. The airplane is empty. It goes down to landing, and here you see they are in the orbit and make CubeSats outside. Yeah, this was today or this week, 2 days ago, at our world. So a new system is flying to the space. Airplane and rocket use the airplane as the first stage, and so we have a successful new hardware. So how to assemble several pieces to make an assembly, and what we are doing is a MiniRover today. And thank you for Valeria to prepare this unit number 9. Start again.
Okay, hello everyone. So yes, today we are going to see lesson number 9. And I will share my screen now. Okay, you should be able to see it by now. Okay, so today we're going to do some assembly practice. So we are not really going to learn new tools, more we are going to practice the tools that we already know in assembly, in Sketch, in parts. So we mix everything together and we learn how to work with assemblies that somebody else made, with assemblies that we need to modify, how to, well, yeah, so, some useful tricks to avoid, especially when we are doing an assembly with lots of parts. Okay, so first I want to see Florin's homework from last class.
Okay. Can you see it?
Yes.
Okay, so the part I made a sketch of are the headphones I designed as a homework a few lessons ago. So this is the front view, and then we have two side views, but just to show that on one side there's this small logo, on the other side there isn't one. So I only put some measurements right here because they're the same over here. And I also made a detailed view from this part over here.
Okay.
And some descriptions, like my name and so on.
Okay, perfect. Yeah, do you have any questions on this homework, Florin?
Yeah, I have one for the detailed view. Like I wasn't able to put more measurements right here, but I think nobody could construct it with only this radius. But if I want to put some more measurements, it's like not working.
Okay, yeah, this is because it's like a spherical surface or cylindrical. So what you would need to do is make a cut view and then indicate the radius there.
Okay, so cut view was here.
Okay.
So
yeah, you can put it.
so
No, I think the first
the other
one.
way. Okay.
Yeah, vertical.
But with 2 points, right?
The first one is okay. The one that you have selected right now, it's okay, and you can put it in the middle. Okay.
Okay.
Yeah, exactly.
And then I can put some...
Yes, exactly.
Okay, thank you.
Yes, sure. Okay. So, did you receive the file that I sent you some minutes ago?
Yes.
Okay, could you open it?
I can try.
Okay.
Let's see. Okay.
Okay, great. So this is the mini buggy that we have used as a laser cut manufactured assembly. And well, you have seen, you know, that we have been printing new wheels, fenders, seats, and other parts to complete the MiniRovers. So what I want you to do today is take away these wheels and put the new ones, put the new fenders, put the seats. Okay, so we can edit this assembly and create a similar one, but with other wheels, with other parts.
Okay.
Yes. So in the folder, you have all the files that you need.
Can you see the folder?
Yeah.
Okay.
Okay, so I think it's a good idea to start with the seats. The name of the file is seat. Yeah, seat for mini buggies. Exactly that one.
Oh, I think it's just opening. It's not putting it into the file right now.
Okay, yeah. Remember, you need to be in the assembly menu and insert component. Oh yeah, this is not it.
It's the same, right?
Yeah.
Okay, let's delete it.
You can click on it. When it's blue, you can delete. Mm-hmm.
What was the name again? Like
Seat
this
for mini buggies.
Seat for mini buggies.
Oh,
So
yeah,
this
it's right.
one.
Mm-hmm. Okay. Exactly that one.
Ah, yeah.
Okay, and please insert 2. No, 4. Yes, sorry, 4.
4 times, right?
Mm-hmm. Okay. So if you want to keep this menu open so it won't keep closing, you can click on the pin.
Mm-hmm.
Yeah, exactly. It closes again and you have to do it again, right? But there's a way, yeah, click, you have the confirm and then abort. Yeah, exactly, that pin. So then it will keep open until you finish inserting parts.
Okay.
Okay, great. So these seats, well, I think you know where they go. Mm-hmm. They go, okay, yeah. So you will notice that the seat is a little bit bigger than the seat coated in laser cut. So
okay,
this is a difference of 0.2 millimeter or 0.2 millimeter. And this is because of tolerances. We made this seat 0.2 millimeter bigger. So when we printed it, it will be the actual size. So this is something that happens in the normal manufacturing industry, that you need to create parts with some differences, so the manufacturer will go well.
Okay, there's this. Okay, so we have to delete some.
Yeah. So I think you got the. Show me the last coincident. They are also in order. So the one that you have made, it's always the last one. Yeah. Okay. So you made them parallel. Mm-hmm.
And.
Okay. Yeah. So you have to be careful with the coincidence mate. When if you want the faces to be coincident or 2 edges to be coincident.
Mm-hmm.
Okay, so in this time we want the faces to be coincident. If you put the edges, then you will not be able to move the seat in X and Y axis.
So
Did I explain myself?
And this one?
Yes, exactly. These are faces.
Okay. And let's pick this one and this one.
Okay, so 1 moment, please, before confirming. Oh, okay, you're already confirmed. Okay, can you go and edit in the last mate? Okay, as I tell you, the seat is a little bit bigger than the laser cut part. So it's a difference of 0.2 millimeter. So if you put one face and the other face coincident, then the other side of the seat, it's going to be 0.2 millimeter separation. You can get closer if you want to see, or you can measure. But yeah, exactly. So these two faces are not coincident, you see? So we will try to put it in the middle. So can you imagine in which way we can put it in the middle?
Like with this one.
Yeah, exactly. So this is a distance relationship, and we just divide the distance that we have. Exactly, yes. So 0.1 millimeter. So it will be in the middle.
Okay.
So this is useful, but when you want to edit parts, when you want to edit sizes, this is not convenient because, for example, if you change a little bit the seat of the size, then you have to change again the distance that you made in this mesh because it will not be centered again. So also a useful way to do it, it's create some reference lines or sketches that you align with the two pieces or two parts. So even if you change the sizes, they will always be centered. But right now it's okay.
Okay.
It's just like an important tip.
Okay. So this one is the right place.
Okay. So we need to place them all.
Let's see what happens. Okay.
Yeah, this is again the same matter. You cannot make these faces coincident because it will not be centered.
Okay. This one is okay. Oh, it's the wrong direction, right?
Yeah. Great, exactly.
So now
also maybe we should check the other ones in case we also made the same mistake. Okay.
No, I think this one. Yeah, they are right.
Okay. Okay.
Oops.
Great.
Yeah, we've looked for it. Okay. No.
Careful there.
The wrong one. Yeah. This one.
Good practice is
it's not
what I want to say is good practice is to try when you are making parts that are the same. For example, right now we are mating 4 exactly the same parts of seats. you want to put the mates in the same way. So choosing the same faces, choosing the same edges always. So this will help you a little bit when you have to edit mates or make changes in the body. It will avoid you future work.
So again, those.
Mm-hmm. Yeah. Mm-hmm.
Is it the wrong way? No.
Yeah, it's okay.
Okay.
Great. Okay, so now we are changing the wheels. So I need you to click on those wheels and delete them. When you delete a part, also the mates that are reference to that part will be deleted.
Like those?
Yeah, exactly.
Okay.
No, do not delete this. I just tell you that when you delete parts, if that part has mates with other parts, it will delete
Okay.
the mates, not the parts, but the mates.
Okay. Okay.
Mm-hmm. Okay, so what we are going to do now is a sub-assembly, okay? So I need you to create a new assembly. And I suggest you to save this one so you won't lose your progress in case SolidWorks collapses or something. Okay, and the parts that you are going to insert are, one is called inside wheel or wheel inside, I cannot remember. And the other one is 2019 wheel. That's the first one.
Yeah.
Yeah. Exactly that one.
Oh no, not this one. No. Do we need some more parts or is it then?
Yeah.
Okay, so
we will need two of the same, so you can leave the pin. Mm-hmm. So it's called, I don't remember if it's inside wheel or wheel inside. Yeah, exactly that one. So we will do two of them.
Okay. Okay.
Yeah, great. Okay.
And
so
now I
now we
should-
will, exactly. So you can see there's a little like step in the inside of the wheel. Can you select that face? Yeah, exactly. That face where it is, where it should go.
Like this?
Yep. Okay, nice. Okay, so now I want you to click on the inside wheel and try to rotate it. No, just clicking and dragging.
Oh, okay.
Yeah, you see it rotates. Okay, so you can see that we still need to put some mates here to stop this rotation. And also if we want one side of the inside wheel and the other side aligned.
Okay. So maybe I can make those two faces first of all parallel. Yep.
Okay.
And
okay,
now,
so maybe if you rotate it now, they will rotate together.
Yeah.
Yeah, exactly.
Maybe we can make this line and this line.
Okay.
Yeah. You know what?
Okay. Yes. It's also coincident.
Yeah. Okay.
Yeah. I mean, we are talking about axis because you want the axis of a line to match the other axis of the line, even if they are not touching. If they are two lines, but in the same axis, they are coincident.
No, there are no.
Okay, yeah. This is because what you selected in the part of the tire of the wheel, it's a curve. It's not a straight line.
Okay.
Yeah. But what you can do is create a little sketch with an axis. So it's only for reference, but you can do that. You can do it in the wheel and in the tire, like in the inside and in the outside, or you can find a way to make it only in one.
Maybe on this plane.
Okay. But okay.
Warning. There's a warning.
Yes. Okay. So what it is telling you is beware, you are in an assembly mode. So it's okay right now because we want to do the sketch in an assembly. But in case you want to do, for example, a boss extrude or cut extrude or something, and you're in assembly mode, you will not be able to do that.
Okay.
So it's like, just be careful with where are you building your sketch. You can also like open the parts and do the sketches there, and then they will be shown in the assembly. But right now it's cool.
Okay. So actually we just need a straight line from this point to this point, right?
I think it's great.
Let's try it. Now we can.
Okay.
Oh, okay.
Okay.
No problem. Let's see what happens.
Okay. I think we'll have a little mistake there. Try coincident.
This one? Or this one?
Coincident is the first one is
Decals. Okay.
Deckungsgleich. Okay. Yeah. Yeah, okay, not possible. Okay. So this is not possible also because they are in different planes. You can see the one on the on the inside, it's higher than on the outside.
Okay, yeah.
Mm-hmm.
So we can delete the sketch.
Okay, try selecting, I think it's top plane. Mm-hmm. Yeah, that one. And build a sketch there. So you remember when you are working on sketch, yeah, you always want a normal view. So you will locate the center. Mm-hmm. You can click on one reference on your. Mm-hmm. Okay, yeah, I think that will do. And be careful to select the line that it's in the same altitude. I don't know if it's one part of the inside wheel or the other part. I don't know if I explained myself. Yeah, exactly. Be careful to select something that it's. Oh, okay. Yeah, I see
It's
the
in the
problem.
middle, I guess.
Yes, it's in the middle. Okay. So maybe you can select the parallel.
Yeah.
Instead of coincident. Yeah. Okay, they are parallel now. Cool. Okay, now try to rotate it to see if there is something missing.
No.
Okay, great. So you also get this message that the item is fixed and you cannot rotate it, right? Mm-hmm.
Yeah.
Okay, so this is how we can use reference sketches to build mates that are not easily built with surfaces, faces, or things that we already have. You can always build as many sketches, planes, axes, and everything that you need, okay? Okay, so now please save this assembly, and we are going to, well, save it in the same folder.
Yeah, this one, I guess.
Yeah, right? And you can name it wheel assembly or something like this.
Okay.
Okay. And we are going to insert it on the other assembly. So we have 5 minutes left for this Zoom session. You know, if anything, when it goes off, we can connect again.
Okay.
Mm-hmm.
So okay, maybe we can try one and then we can insert the other ones.
Mm-hmm. Yes. Okay, so, well, it's important to notice that you can make assemblies and then put these assemblies in other assemblies.
Mm-hmm. Okay.
Okay. Mm-hmm.
Is it like enough space right here for it, or do we need to change the distance of this?
Yes, we the distance. What you need to move is the. I forgot the name of this word. Yeah, exactly. Yeah, exactly, the nut.
The length of the stick you can change then.
Yeah, the length is all right. I checked that, but you just need to displace that nut. Mm-hmm. So you can also put some mates in that nut, because I believe it's not even concentric with, yeah.
Yeah, okay.
Mm-hmm.
Oops, no, I didn't want that one. I have to zoom in. No.
I think you selected OK, and now you created that mate. That I don't know what it is.
Okay.
Well, I think you selected, okay, I'm not sure.
No.
Yeah, it's that one.
So I want this face.
That face. And what do you want to do with that face?
I want to make it coincident with this one.
Oh, okay. Okay. Maybe you put a little distance in between them.
Oh, okay.
Like 1 millimeter or so. Okay.
And now I want what can we fix?
What are you going to do?
I'm looking for another relation.
Okay. So maybe we want the wheel to be concentric with the axis. Or with the axle. So yeah, okay. So try selecting that face, but sometimes this is not possible to select as concentric, but wait a second. You have some options in mates. You have two menus that are closed. Lower. Yeah, exactly. So you need to look for one that is at the screw relationship. And look for a Vita. Yeah. Or mechanical again. Mechanical. There, yeah, the Schraube. This is the screw one. So maybe you need to unselect the one that is on the top.
This one?
No, you have selected something in standard mates.
Okay.
Yeah, exactly there. You have something selected and click it.
Not possible.
Okay. Okay, then instead of selecting the face, the cylindrical face, only select the edge. Okay. So I'll give you a tip now. If you want to move some components away because you cannot see, then you can right click on them and yeah, that it's for hiding. So it's always there, but now we can see a little bit better. Okay, yep. So select the edge.
I think I have done it.
Oh, okay, okay. Then look again in mechanical mates and select the one that is a screw. Okay,
I don't know.
Okay, so this is what we're gonna do. You'll unselect the axle and we will select other things that we are also concentric to this axle, okay? So let's take a bit. Yes, but this will not work for you. Okay, so right now we are going to learn how to assemble the wheel. Okay, so you should see my screen now. Okay, yes. Great. So this is a wheel that we need to assemble. You can see we have some mates here, and it's, we will insert it as a sub-assembly in our main assembly, which is this one. Okay, so what I'm going to do first is delete these wheels. I only click delete on my keyboard. Okay, I can also click them all at once. So delete more quickly. Okay, no. What happened here? Yeah, okay, great. Okay, so I click the normal insert component and I want this assembly. So I'll click it here. Okay. So I will assembly in this part. So first I need to move this nut because it's interfering and I want to put the wheel in this part. Okay, but you can see it's not really concentric with the axle, so I want to make it concentric. Okay, so what I'm gonna do first is create a mate between this face and this face. So they are coincident now. You can see it's very important to notice that even if you put coincident, they cannot be touching. So right now they are touching, but they are coincident, but they are not touching sometimes. So you need to put more mates if you want them to be completely defined. Okay, so watch out in this part because this is an axle, and you may think that you can create a concentric mate between this axle or this helix and maybe this face. But, oh, okay. So right now, yeah, it was created. But sometimes you cannot do it. But, okay, well, you can see that the relation is now called tangent. Not really concentric, so be careful with this. Okay, but we see it's concentric now. You can also try here some mechanical mates and use a screw one, especially when you have a helix and a line. So let's see what happens with this. Okay, mate. I'll click not on the face, but on the edge. Also click on the helix. Okay. And okay, yeah, it's screws also blocked. I think I should click the face. Yeah, okay. So what I did right now, it's not selecting it. So when I click here, I select the helix, but when I click a little bit here, I'm selecting the face. Okay, so it's different to select the helix and the face. Okay, so I selected the face and now I can insert the screw relationship. I will click here. Okay, now I confirm. So the screw relationship is made, well, yeah, for screws and bolts, so you can turn something around them. Right now it cannot turn because we already made a relationship of coincidence here, but right now it's fine. Okay, so you can also see that this axle is not centered. Okay, so we want it also centered, and we also need to make this other part. Okay, but you already know how to put this one, so right now we'll ignore this one and just focus on how to center the axle. Okay, so there are many ways to solve this problem, and it depends always on the designer or of the way of thinking of everybody. But what I like to do is create some reference planes and align them. Okay, so I think I already created a reference plane on this one. Okay, let's see. Okay, so here I have my axle. Okay, so I look for it here in my operation tree. I will open it. I will open the features, which I open here my complete part, and then I click on this plane that I already made. Yeah, so this plane is exactly in the center. I created it before. So what I will do is also create a plane in the middle of my buggy and then align them. Or maybe it's also created. Let's see. Let's see. This one, yeah, okay. So this is where it's important to make everything in the origin, because right now this plane cuts exactly in the middle and it's exactly what I need. Okay, so I'll select this plane. I will mate it. Okay. Open the features. Let's select this plane. Okay. So they should be coincident. Okay, yeah, I'm getting some mistakes. Okay, so let's delete this image. Okay, so maybe this could happen if this plane and the plane on the middle were not parallel. So this is where geometric problems happen, even if they are just 0.0001 degree apart, then they are not parallel and you cannot make them coincident. So what I could also do is, okay, let's measure this part. Okay, so right now I don't want to see this. Okay, remember if you want to measure, you can click on evaluate, measure. I'll click on this face. I'll click on this face. Okay, so let's see. The distance is 105 millimeter. Okay, so what I will do is create a image. Yeah, this is what I tell you that you can. There are many ways to solve the same problem. So what I'm gonna do is make this one with the mid plane, with this one. Okay, I'll put some distance. Okay, so here I have a problem. So this is the reason why it failed. So the problem is that the angle between them is 179.999823. So they are not parallel. So this is a problem that I had before, and this is why it failed. So remember to always put the correct mates, so this won't happen. So if you need to put some perpendicular parallel mates to avoid this kind of mistakes. Okay, so let me see if I can get a distance. Okay, remember you can always type the equation instead of making the equation yourself and then typing it. So let's see. Yeah, okay. Yeah, so this is a problem again. The 180 millimeter. Okay. So we have a problem here that it needs to be solved. Let's see. Okay, so this problem should be solved from the beginning of the assembly. Probably we have a little bit of angle in these parts, in these bended parts. So they are not perfectly perpendicular, and then we have this problem. So I would prefer to keep moving and show you how to assemble the wheel instead of how to correct this mistake, because this mistake will take me to try to understand everything, all the mates are already made. So right now I'm just going to pretend that this is centered. Okay. And I'm gonna show you how to assemble the wheel. Okay, so I'll create a new mate and I'll click on this face and this face. Okay, so I don't want them coincident, I want them 1 millimeter apart. Okay. Yes. So we see. Okay. So they're 1mm apart now. Okay, I'll create unmade to make them coincident. Okay, so remember here you have several options to make your choice. For example, I can select for coincident, for concentric. We have many circles here that are concentric. I have this face, I have this edge, I have this other circle, I have this face, I have this circle. So you can see everything is concentric here. And also here I have several options. So I have this face, I have the helix, I have this outer face. I also have this hole here, this, okay. So what I suggest you, the same as always, is try to do it in the same way in the 4 wheels. So you will avoid some mistakes if you try to do it that way. Okay, so right now I'm going to select this edge. And I want to select, okay, so I will remove this for now. Yeah, I want to select this other edge. No, not that face. Okay, this edge. Yeah, so they're concentric now. Okay, so now, right now I hide the axis, so I will show it again. So you can see the things that you have hidden are in this color. So I'll click on them and show them. And also this one. So right now it's easy because there are only 2, but if you hide many of them, you can always select everything and choose to hide them or unhide them all. Okay, so let's see the view from the top. Okay, so yeah, you can see this is 1mm apart. And here we are invading this, this bolt, this nut. But this is because our axle is not centered. So what we can do now is create a mate, for example, between this face and this other face. So they will be coincident. Yeah, okay. Okay, so this is how you assemble the wheel. And right now the axle should be fixed because of the mates we made, but it's important to say that it may not be centered and we really need to take care of that. Yeah, it's fixed. Okay, so this is how you assemble the wheel. Okay, so I will go now with the fenders. So I have my fenders here. They are the back left, back right, front left, and front right. So I will also open one. Okay, I will open the front right is, I think it's the standard one. Okay, so this is it. Okay, so I'll assembly one in the front and one in the back because they are a little bit different. Okay, so first you notice that we need we need this face to be parallel with this one. I'll click only parallel, not coincident. Okay. And we need a fender.
Please use opposite side.
Yes.
This is the wrong side.
Yeah, I know.
Okay.
This is what I want you to notice. So first of all, you need to check that the fender is that this part is covering the wheel and not on the other side. But you also need to check that the fender looks in this part, that it's on the front. Okay, so this is the front right as we have talked. So I'll put it on the other side. Yeah, on this side. I'll also make it, I'll turn it and I will make it concentric. Okay. So let's choose this. This one. And select this one. Okay. So they are coincident now, but you can see the fender is also not in the correct position. So I will align. Yeah, okay, no problem. Okay. So this is the correct position of the fender. Okay, well, we still need to put some more meats. Okay. So what I'm gonna do now. Okay, so here we may have a little bit of misplacement because of the tolerance we made in our fender to fit. Okay, so let's get closer to see. Yeah, okay, so this is what I'm talking about. You can see that this axle is concentric with this other axle, but in this part, the fender does not fit the rover. So this is because of the tolerances we made, because this bended part may have some difference between one rover and other rover. So what I'm gonna do is I prefer that this face matches this part, and then even if this is not concentric, we know that this is a mistake for tolerances. Okay, well, not a mistake, but this is an issue that we have because the way we build the fenders. Okay, so I'll also look for the mates. Yeah, so this is concentric, and I will delete it. Yes. Okay. So, okay, let's see. Okay, so you can also see that this is not the same length. So if I put concentric on one and concentric on the other, excuse me, coincident on one, the other will not be coincident. So I need to center them. So what I'm going to do is also create a mate. No, let's measure first. Excuse me. Measure. Okay. Now measure this and this. Okay. So we have 2.4 millimeter. Okay. And I will measure. No, not this one. Okay, so these are not even parallel. Okay, no problem. I'll measure this one. No, not this one. Okay, 2 millimeter. Okay. So we have 0.4 millimeters. So I'll create mate between this face and this other face. So we have a distance of, we said, 0.2 millimeter. Okay, so let's center it. Okay, so right now, maybe not Well, yeah, it's a little bit noticeable that this axis is not concentric with this other face, as we have talked. Okay, so we also need to put more mates here. So first I will mate this face and the face here. This will not also be possible. Yeah. Okay, so this is also because of the mistakes in the assembly, that they are not parallel, perpendicular. So let's see. Okay, let's see. Okay, yeah, we have a difference of 12 degrees, but we can create a distance here. So I will make it 1, so they are really close. Should be possible? No. Let's try again, changing the degrees. Change it to 0.
Is it possible to just select the edges, or is there also a problem there?
They are not parallel. You can see it here. They are not parallel. So what we can try to do is select points. For example, that this point can be coincident with this one. So we will need no parallel relationship. Let's see. Looks like it will not be possible. Oh yeah, but no, it is going to be possible. So let me try this face. I truly don't know which faces of this assembly are right and which are not. So maybe if we try other faces. Yeah, okay, so this face is cool. Okay, so I'll set a distance of also 2 millimeters. Okay, and we still need to solve this. Okay, so we need to find another reference that will be useful for us. Okay, so let's see this one. Oh, okay, yeah, this one is useful. So this face was correct and this face was not correct, but this is what I tried to tell you. If you cannot do it with one mate, then try to do it with different selections. Hello. Okay, hello. So let's create a distance of 1 millimeter. Yeah. Okay.
Yeah.
So Firina, this tolerances are important because the 3D printer need this, and when you assemble it, then in one rover is it too strong, in another rover is it not strong enough. But what we do is that we take glue and glue this fenders inside. So when you have glue between the rover and the fender, then there is a small distance. Cosma, please silence. Then there is a small distance. So the glue has also a thickness. So when you put this fender and the rover there, a drop of glue, then everything is fine. You must only wait until this is correct. Yeah? So, okay, we have a wheel, we have a fender, and then we may make a seat, and then we have everything assembled. We must only make it 4 times.
Okay. So just remember for fenders that on the back part, it's a little bit different. First, you will need to remove this LED because the fender goes right here. I will just insert it so you can know what I'm talking about. Okay, so this is the back, right, I'll choose, yeah, back left, okay. Okay, so this is a fender, and you can see it's a little bit different because he's here, it's missing like a little part. Okay, so this face should be coincident with this face. Okay, so it's a little bit different from the front one, but you already know how to assemble it. Just take care of that. Okay, now I'm going to delete it for now. Okay, and I will show now how to do to assemble the seat. So I'll insert the component and look for the seat. Okay, so pin, insert 4 seats at a time. Well, we're only assembling one, but it's more quicker. Okay, so what you will notice here is that if I measure from here to here, it is 40 millimeter. You can see it here. And if I measure from this seat to this seat, then it's 40.2 millimeters. So this is a little bit bigger, okay? So some coincident mates will not be useful right now if we want the seat to be centered. So what I'm going to do first is make this face and this face. Okay, now make coincident this face and this other face. Okay, not in this way, but in the other, then I click here. Okay, great. And then I need to center this. So what I will do is select this face, this face. They are coincident now, but I don't want a coincidence, so I click here on distance. And then I want a distance of 0.1 millimeter. Let's see. But I want it on the other way, so I also flip it. Okay, and confirm. Okay, so this is how to assemble a seat. You can see now that it's completely fixed. Okay, so you will repeat this with the other 3 seats. And I think this is all that you need to know to assemble the rover. Do you have any questions?
No.
No, yeah, maybe you can share this drawing now and to Verine, and she assemble it with our, for us, okay?
Mm-hmm. So do I share this assembly with Verine and she will do it in her screen?
Yeah, you can stop the conversation. We started again with, no? Okay.
Okay, but okay, the Zoom is about to end.
Yeah, no problem. I can record the next.
Oh, okay. Yeah, no problem. Okay.
So do I change something in your assembly or in the one I've done before?
Ralf?
Only send the assembly to her and she can finish it. No?
Okay, but should she use her assembly or the assembly that I was making, because they are almost the same?
I don't understand. We have seen your assembly now, and Verine should finish this.
Okay.
That's it, yeah. Because
Okay.
I make now several scenes, and then Verine's scene is different than your. It looks like you make a movie a day and night, but it don't fits together. Yeah. Verine should start with the assembly of you now.
Oh, okay, yeah, this is a question. Okay, thank you. So then I will close the Zoom and we start again.
Okay.
Yeah. Yes.
So let's start maybe with this fender.
Okay.
So
Is the
right or left?
Left. Mm-hmm.
Yeah. This one. Yeah. Okay. The first media was this one, concentric with this one, right?
Yeah, I think that is great.
Okay. Oops. Yeah. Okay.
Okay.
So now we can still make this. So we should make those faces perpendicular. Was it this one?
Okay.
With a distance of 1 millimeter, I guess it was.
Yeah, 1 millimeter is great.
Okay. And now we can still rotate it. So we need to select 2 points, like for example this one and this one.
What you can do is select 2 faces and make them parallel.
Okay, so first
I think that will be, yeah, that will be useful.
Like, I guess it was, no. Okay, I think I have to.
We will have to remove the concentric mate because as I told you, the fender is not really concentric with the axle because of the tolerances that we made.
So, okay. Like this one.
Yeah. Yeah, now you can select the faces and
okay.
Make distances between them. So it was 0.2 millimeter. Great. Okay.
And then we had this one and this one, right?
Perfect.
So let's see if we can still rotate it. No, it's fixed, I guess.
Okay, perfect. Great.
So we are done with this one.
Yeah.
So I can bring the axle back right now?
Yep.
This one.
Okay, I think you have another part that it's hidden.
Yep, must be. Where is it? Like all these parts are colored.
Okay. So the axle got lost. Do you remember the name of the axis? Is it also in the back or not? Oh yeah, I remember. I know what is happening. So it is on the top of your operation tree. So this is what we are seeing on the top is part of the axis.
This one? Or this one? Or...
Go to the top. Go scroll up. On the operation tree. Yeah, okay. So
okay.
There is it. There is it. One axle and the other axle. Yeah.
There it is. Okay. So we could maybe build the wheel this one.
Okay, yes.
Or let's take this one because the nut is already removed.
Okay.
No, not this one. This one.
Okay, be careful. This is what I tell you that that you need to not mix one folder with the other one. So
I
you
didn't.
need to
Let's
okay.
see.
So open the menu of opening folders. Okay. So now you need to be sure that you are in the correct folder, in the one that I sent you. Yeah, exactly. So we were not in the correct one, I guess.
Okay. Ah, yeah, okay,
Yeah.
perfect. So, first of all, let's create a mate between this face and this face.
Okay, great.
And now we can select, I guess it was this face, and I want to select the face. Is it the face? Yeah. Okay.
Okay, try. Yeah, okay, concentric. Okay, yes. Let's see how it looks. Okay, you can try to move it and see what happens.
Like a
Okay.
normal wheel. And now we just have to, like the axis. Too small, I would say.
Okay, it's too small. Or the wheel, yeah, okay. So the axis may be too small. Okay, so we can edit this, but I don't know if we should do it right now. Ralf? So we need to edit the axis, the axle.
Longer.
Yeah, longer. So it will take a little bit of time. Is it okay, or we proceed?
You don't need it too much. Only make a show.
Okay, then.
Longer, you can make it later.
Okay, yes. So we do not edit it right now.
Okay.
Yeah, we keep going with the other wheels and the other fenders.
One more seat, right?
Yes.
And the rest was homework, right? I don't know.
You already made it, but you can try also with the back fenders that we haven't made. Like you have already know you already know how to put the wheels, put the front fender, the seats, and we can do it with the back fender.
Okay. Edge. Is it the right direction? Yeah.
Right. Yeah.
Okay. And one more fender, right?
Correct.
Oh no, the wheel's already assembled. Maybe we can click on the eye that we can't see.
No, okay.
No?
You can hide the wheel, so it is not a problem for you. Or you can try to make it this way also.
Okay.
So
The left back fender. Okay. First of all, this face needs to be mated with this face, maybe?
Okay, yeah, perfect.
Yeah. Yeah. And now this face and this face, right?
Yeah.
Okay. No, the other way
Maybe
around.
try to flip it. Okay. Yeah, I think that's correct.
Okay.
You will also need to delete that LED that it's on that way. Okay. Yeah, okay, the fender is correct.
It just
but there
needs, yeah, okay, sir.
It needs 1 or 2 more mates.
Like, I think it's not, like, this isn't possible, right? But it's not.
Okay, then do not make them coincident, make it with the distance.
Okay.
Yeah, this is also because of the tolerances, because that part that that is bended, that has the LED, it's always bended in different angles. So we also made some extra space there.
Maybe 5 millimeters?
No, 1 millimeter is normally.
One. Okay.
1 millimeter, it's a lot of tolerance. It's a gigantic tolerance. 0.1 millimeter, it's also very big. So a very tight tolerance is 0.01.
Okay. And now maybe we can try to make this and this.
Okay, also with distance.
I think, yeah, there's like a 0.00001 difference between the angles.
Yeah, there are some problems. Okay, so try to select other faces so we can.
Maybe like this one and a distance.
Exactly, like this one.
Okay. And parallel. Where aren't they? Let's see.
Okay, they're full now.
Okay. So maybe we can make like this one parallel to this one, and then it would be like concentric to it, but I don't know.
No, not really. Okay, try again to select the faces inside the fender mouth.
I just want to. Okay. Which one?
Okay. Yeah, that
or
one.
Maybe
that
we can use this one and.
Okay, and the bottom one.
Yeah.
Okay, try it. Yes. So this is also mistake that most has happened because these parts of the mini buggy are made in sheet metal module. Okay, great. So these are made on the sheet metal module. On the sheet metal module, you can have sheets of metal and you can bend them or unbend them or make different operations, like if you were having sheet metal. So this may have happened because of that.
Oh, look, here's a problem.
Oh,
it was not right. Okay, let's change that.
Yeah, okay. I'll also give you a tip. Where you don't know which are the mates that you need, you can click on your seat. On your on the other one, the white one. Yeah, okay, and right click. Yeah, you can also locate it there, but right click, and there's somewhere when you can see the mates that you have. I think it's like a clip with an eye on the top of your where you can see a lot of icons. Yeah, exactly that one. Yeah, so you can see. So you also notice that they have numbers. The relations or mates have numbers. This is the 86, 87, and the 3.
Mm-hmm.
So you will be able to locate them.
Okay.
Okay, great. So we fixed the fender, right? Moment. Okay, so I think you can insert. Okay, you're changing the colors.
No, I was just.
Oh, okay.
It
Okay. Okay. Okay, so you can assemble the other 2 wheels on the seats,
okay.
and you are missing 1 fender. So this time, when you assemble the seats, you can try mating them with the seats that you already have. So I explain myself. You can create this mate now. Okay, great. Confirm. Okay. Now, instead of making a new distance mate, you will select your top seat on one side, on the side. Yeah, exactly, that face.
Okay.
Uh-huh. And you will mate it with the other in a coincident mode.
This one?
Uh-huh. So you are creating exactly the same.
Oh no, I think
well,
it's
yeah, okay. Yeah. Okay. But I don't know if you are understanding me that this is the same mate created in different way.
Yeah.
But this is useful because if you want to edit 1 seat, then the other 3 seats will be also edited. And you will not have to create 8 more mates. So it's a good tip.
Yeah.
Maybe you can explain a little bit what you are doing next, so everybody that sees this video can know.
So now we have assembled all the seats. So maybe we could continue with the last fender.
Okay.
So first of all, we need to insert the component. It's the back right fender. Okay. And now we want that this face and this face are touching faces. Okay. And this face and this face should have a distance of 1 millimeter.
Mhm.
Let's see.
I think they are.
Not really. What happened? Okay, let's
Okay.
delete the meat, maybe. And do
Okay,
it
I would
again.
get a little zoom out so we can see the position of the fender. Okay. You can also see
Oh yeah, it's
how
1
the
millimeter,
fender
but
is located.
not the right side. So
But-
maybe we
okay.
just
Edit it. Okay.
Yeah.
Good.
no,
Looks
it's right.
much better. Mhm.
Okay, so we can still move it like up and down. So we need to make, I guess we use this one and this one. Made them parallel.
Okay.
Let's see. Oh, okay, no. Maybe we can use like,
I think we use the bottom part of the fender and it works.
I remember it, yeah.
Mhm.
So let's see how we can select this. Okay, there's so much stuff around. So
Yeah, this is a problem sometimes when big assemblies happen, but this is what I told you. You can always hide
this
them.
one
Mhm.
and this one. I wasn't selecting my, okay, again.
Okay,
Well-
you can actually select them and then click on mate, but
Okay.
you need to click on shift on your keyboard so you have them, the both of them selected,
Let's
or
see.
one, but
Nope.
yeah, maybe just hide some components so we can
Yeah.
clearly see.
It's not the
You
whole
can
video.
also select them like in a box,
Yeah.
so you select many of them at a time.
Not the wrong one. Like, I think he has a mistake or something. Should we worry about it?
No, it's okay. So this is a traffic light. It means that your model may have changed. It means that if you are editing, if you have also this model open on another window and you edit it, then it will also reflect these changes in this assembly.
Okay.
So it's not a mistake. It's only like a warning, like, okay, be careful. This model is not updated. So if you want to correct it, where you have the save assembly button, yeah, you have a traffic light. Where where it says save, below of that you have a traffic light.
Okay.
Yeah, that traffic light, and then you click on it, and it will refresh everything.
Yeah.
And that's all. But it's not any mistake.
Okay. So the last mate, I think we should delete it.
It's not really important. It's like like an extra mate, like it's over defining. What you will need to do is set a distance.
Yeah. This one, like what was the distance? 1 millimeter?
Yeah, 1 millimeter. No, it was 0.2, I think. Yeah, I think it was 0.2.
So let's see if we can still move it.
Okay.
Okay, perfect.
Great.
Now we want to see our wheel again. Not the whole one. Where is it? It's here. Let's see. Okay. Okay.
Okay, great.
Maybe just make those touching, and it looks nicer.
Yeah, you can also make them concentric.
Okay, it's impossible to look through it.
Yeah, so it gets
There.
a little bit difficult to move in little spaces. Mostly because when we rotate the part, it rotates about the centroid. So when we rotate all the rover, we are rotating about the center of the rover, the mass, the center mass. So it gets a little bit.
So now there are just 2 wheels missing. Do we still have time, or?
Yeah, I think we still have time.
Okay.
Okay, we still we have 10 minutes more. 10 more minutes.
Oh, look, I just noticed the profile is the wrong way around. Like it should be like this.
Oh, okay. Well, you know how to fix it.
Yeah. This one is right.
Yeah. Yeah, that is important.
Let's take this one away and hide it. Here's still okay. And we want this one. Okay. So now we can bring back the nut.
You need two references, and you only selected one.
Oh, I thought this one was selected too. Okay. Okay, no.
Yeah, I think it's all right. I know. Okay, I think you're selecting the outside of the knot. I'm not sure, but I think you are selecting. Yeah, it's easier to move them not.
Mm-hmm. So. Okay.
Good. I think. No, I think it's okay. Yeah.
Okay. So again, we will just do the same. This one.
No, it's the other way around.
Yeah.
Yeah, exactly.
Okay. So our rover could drive right now.
Yeah, could drive on the moon.
So, Farine, some extra work now. This is the camera holder, left and right on the front seat, and then the telemetry, what you have. I sent you a photo. We printed the telemetry. This looks nice. You see this on WhatsApp.
We have 3 more minutes, and I think I didn't put the camera holder inside, only the telemetry or the files that I sent you.
Okay, then we save it and make the rest with the next short meeting.
Yeah.
No?
Okay, and Birin, can you measure from one knot to the other knot? So we know the distance, and we know which size of the axle we need to have. Try to select the notch in the top part. Yeah, exactly that point. Okay, so you can get far away. Yeah, scroll out.
Okay.
Oh, okay. Oh, yeah, okay. Yeah, this is the distance. 118.75. Okay, so this is more or less the length that we need for the axis. Maybe a little bit shorter.
This is
because-
also good to know for our production lines then, no?
Yeah. Okay, so this is it. Do you have any questions?
No, thank you.
Okay. So then we see us on the next lesson
Looks
to continue
beautiful.
with telemetry and camera holders.
Okay.
So today there is no homework.
Okay.
Okay, so I don't know if you have anything more to add, Ralf?
Thank you for the
So
lesson.
now we're going to use Ferin's screen again. So she will assemble the camera holders and the telemetry box. Your microphone?
I need the permission to.
Oh,
share
yes,
it.
sorry. Now you have it.
Okay, thank you. So, first of all, let's insert the new component. Camera holder. So they're right here and here. So they have to touch this face. Yep. So we can still move them in this direction. So we need one more made.
Pass auf, die obere Kante, die muss ein bisschen höher sein. The upper shape must be 4 millimeters higher than the seat is. 3 or 4.
Okay. Let's see. Okay, I know what the problem is. So this line and this line 4 millimeters, but in the other direction. Let's say -4. No. Okay. I don't know why I can't click on those. Your microphone is muted. Valeria, your microphone is muted.
Oh, sorry. So I think you must have other mates that are preventing you to do that. So, okay, no, we don't want that, right? Check your other mates, the mates that you have done before. Check your other mates. Go out of this menu. And check.
You made a coincidence between the surfaces. Use the edges.
Let's say they should just be parallel, maybe.
Try to move it in the position that you want it.
Now it's
Okay, so you see the problem.
yeah. Okay. So actually what we maybe could do is to split the surface. I don't know if that's possible, but
Split the surface? What do you mean, or
like
what do you
into
want
two
to do?
parts. So then we have this part, and we can make this one coincident with this one.
No, remember that even when you make one face and another face coincident, they can be coincident even if they are not touching, if they are displaced. They just need to be in the same plane. So you don't really need to split a surface.
So I can make that coincident again.
Yeah, exactly. Okay, now try to move it and see what happens.
No, one more. Wait. This one should be coincident too.
Okay, yeah. Now try to move it.
I can't move it.
Okay, exit the mate menu. Okay, try to move it. Okay, let me see your mates. Or click on your camera holder so we can see the mates that we have.
We have those three.
Only two? Three.
This one, and this one.
Oh, okay, so this is
I know we can't. Yeah.
No, this is a 4mm. Yeah.
Yeah.
No. This is the one that is preventing us to move. Okay, so now
So
move
now
it.
we can move it.
Okay, exactly. Pre-position it and then try to make it again. You can also make it between, I think I know what is the problem. So if these lines are also not parallel, you cannot set distances between two lines that are not parallel. It makes no sense. So you can choose 2 points.
But they should be parallel, right? Because they're just touching each other.
Maybe, I'm not sure. Okay, so let's try again with 4mm.
Now it's working.
Okay, great.
Yeah. And now, yeah.
Okay, great. Now it should be fixed.
I can't move it. Yeah.
Great.
So now the other one. This one. Okay.
Try to mate it with the other one, with the other camera holder.
Yeah. No.
No, it didn't work. Maybe you will need to mate the faces. Well, no, do it your way. It's okay.
I think we should delete it because.
Okay. Yeah, it's
like this
over-defining.
Okay. So maybe they're not. Oh, they should be parallel, right? Because they're no. Okay, never mind.
Yeah. Depends on a lot of geometry.
Maybe we can use those.
Okay.
Not the point, of course. Oh, it's working too. So. Isn't it?
Okay.
No.
Yeah.
No, it's not working. We have to
Okay.
select the edge.
Okay, try. Okay, I think it's working now.
Let's see. No.
Okay.
Okay, so maybe we should just use
Yes.
this
Mhm.
relation.
Yeah.
Okay.
Okay, looks nice. Mhm.
Yeah, like an animal or something with the ears.
Yeah. Okay, so
Okay,
don't forget to
so-
save. Don't forget to save your assembly every now and then, so you will not lose your track.
Okay. So the telemetry.
Yeah, so it's an assembly. You will find that there are some telemetry parts, but choose the assembly.
This one is an assembly.
Mhm. Okay. And I think you will
Oh,
need to
so
remove
cute.
a black part.
This one?
Yeah, exactly that one.
Okay. Okay. It looks
And
a bit different than it looks on a real moon buggy, but let's rotate it first.
Mhm.
Like a small airplane. Yeah. Okay. Okay, there it is.
Okay. You can also remove the seat and everything if you need to.
Yeah. And we could make it parallel to this face, maybe.
Okay.
Not touching, let's say 5mm.
If you don't know, you can also make it parallel, and it's parallel, not a distance fixed.
Okay. Nope, this one. Okay.
Mhm.
Where is it? Okay. And now it needs to be like fixed in this dimension too.
Okay. Yeah, it needs to be centered.
Yeah.
And
Maybe we could measure the distance from here to here and from here to here.
okay.
Then we make like it parallel to distance.
I suggest that you hide the seat so we can see a little bit better.
Okay.
Maybe also that part. Mhm.
This one?
Yeah.
But I think I needed to measure it, right? To make.
Okay, yeah, if you're going to use that, it's okay. Mhm.
So 29
Mhm.
millimeters. And what do we have? 9.5. Now it should be centered.
I think it's centered.
Yeah.
Yeah, I think it is.
Okay.
Great.
So we can still move it. So maybe we should make this one like not parallel, but with a distance.
So most to the front as possible.
Okay. So actually, we could just say that those surfaces should be touching. Is it possible to
You can use the hole down.
this? But like we have, I think, like
No, use the opposite side.
this one.
No, opposite side from the hole.
This one. Okay. Okay. Okay, so there's still a small distance, but I think it's fine. Now it's fixed.
Okay, great.
So we can bring back all our pieces now.
Okay, I think this is complete. So you can show us a picture of the whole rover, how it looks like.
So we've now added those camera holders and the telemetry right here.
Great. Yeah. Okay.
You are muted, Ralf.
Okay, Firine, is there something missing what you want to add? Maybe you share your screen again?
Okay. We could add the cameras and like the lights, maybe.
Okay, this will be your homework. You can make what you want, a camera or a seat belt or what else. No? But what I want is that you color the moon buggy to the Calypso. Maybe make some textures over it so you know the colors. And next lesson you explain to the students how to color a buggy. Successful. If you want, you can make also a rendering with nice shining effects. You know how it works. Yeah,
but it's not working on my laptop.
Ah, yeah, okay. Yeah, doch, it works, but it needs time. But pay attention. We have some pieces. The seat frames are in silver, in zinc. The seat pillows are in color, in blue. And the frames are in black or in blue by Calypso. You have, but I think you have enough photos where you can look inside what is what. No? Okay. Maybe Valeria at the end, last mission or next mission, next unit is that you explain her how to map a logo on the fender and on the seats, because then we have also some sponsor logos. Then we have, after 10 units, a really nice looking rover.
Hey, yeah, sure, I can do
Thank you,
that.
Firine. This was a good work, and also to you, Valeria. Very nice.
Thank you both.
Thank you.
Okay, so see you on Friday in the next lesson. And
See you. Bye.
thank you for attending this lesson. Bye.